All right, and here we go with the end of section 7.6. The last quadrilateral we are going to learn about here in chapter 7 is called a kite. And a kite is one of those things that almost sounds like a made-up thing. Like, really? We're going to study something about that? It's called a kite? Yeah, we're going to run with that. So our definition of a kite, you'll notice, is different than anything else we've talked about. A kite is a quadrilateral, 4 sides, but it has 2 pairs of consecutive sides that are congruent to each other. And then going along with this, opposite sides are not congruent. So I've drawn a kite for you here, and I didn't just freehand this, guys. I did this on GeoGebra, so I believe what you're looking at here in this figure is about as perfect as I can make it. You've got 4 sides here, obviously. That's why it's a quadrilateral, and 2 pairs of consecutive, meaning in a row or next to each other, sides are congruent. So I think you guys can tell right here that line segment KE is exactly the same length as line segment KI. That's what we mean by consecutive sides being congruent. They're right next to each other. They share a vertex here at K, and those 2 sides are the same length. But that's one pair of consecutive sides congruent. There needs to be another pair as well. And that happens when we notice that line segment ET and line segment IT are congruent to each other as well. Again, those are consecutive sides in this quadrilateral because they both meet right here at point T. So that's what a kite looks like by definition, everybody. A quadrilateral with 2 pairs of consecutive sides congruent. And notice, though, opposite sides cannot be congruent. I put that in there because technically, don't put this in your notes, guys, technically, if I put a double tick mark and made all 4 sides congruent, you could technically argue that there's one pair of consecutive sides congruent and there's a second pair of consecutive sides congruent. So you could argue then that without this statement right here, technically what I have drawn here is a kite. But I'm hoping you guys recognize that would mean that we have 4 pair congruent sides there. That would make this figure a rhombus. And a kite is not a rhombus. So that's why that last statement right there, oh my gosh, what did I do? That's why that last statement right there was really important. Okay, gotcha. Yeah, this is where we want it to be. Okay, guys, that's the definition of a kite. Now, let's talk about some properties of a kite, and there are 4 of them that we need to know right here. The first one, everybody, I'll just call this property number 1, the diagonals of a kite are perpendicular, and there's a theorem in our book that tells us this. It's theorem 725. So this is probably going to get messy here, guys, but if I were to draw, let's do this, and I tell you what, let's make these diagonals, let's do something different here. Let's make them this nice orange color right here. Okay, the diagonals of a kite. So if I were to draw one diagonal from K to T right there, and the other diagonal from E over here to I think it's pretty easy to see and to understand here, those diagonals are going to be perpendicular. The reason for that, guys, is because, don't put this in your notes here, that this triangle right here, okay, I'll do that one in yellow, and then this triangle right next to it, I'll do that one in blue, end up being congruent triangles. And that means that angle 1 and angle 2, I'll call them here, have to be congruent. You can also tell from the diagram they have to be supplementary there. They form a linear pair. So if 2 angles are congruent, meaning they're the same, and they're supplementary, meaning they add up to 180, each one of them would have to be 90 degrees right on the nose. So that's what makes the diagonals perpendicular. It's not just because it looks that way. Okay, what else? This gets a little wordy now. In part 2 here, the second property, this again is a theorem out of the book, theorem 726, one pair of opposite angles is congruent, but not both. Now, this gets really wordy if we try to write it out here, guys. The pair of opposite angles that are congruent here, guys, it's either angle K is congruent to angle T. Think about that for a second, and if you believe that's the case, or angle E is congruent to angle I. It's a question of symmetry, and most people can see that in a kite, it has one axis of symmetry along a diagonal, but not 2. This kite is not, you guys, it is not symmetric if we were to fold it along this horizontal diagonal. Okay, doing it that way, angle K and angle T are not going to match up perfectly if you folded it that way. But it does have, in this case, a vertical axis of symmetry going right down the middle here. Angle E and angle I are going to match up perfectly. Now, most people can kind of figure that out on their own as they're going through it. Technically, if we were going to make it wordy right here, we'd have to say the two angles that are in between the congruent sides. So that's why we're talking about angle E here. And then, I just realized, guys, hang on a second. That was a goof up right there, and that wasn't supposed to be there. Let's get rid of that. Okay, then actually it's the angles between the non-congruent sides. My mistake there, guys. So that one and that one. Again, that gets difficult to put into words, so usually we let you guys kind of eyeball it and say, okay, I think we can tell. I still want to get rid of, this guy here. All right, you just go over there. Okay, so it's going to be this big angle E here that's going to be congruent to this big angle I. Okay, so that's part 2 here, the second property. Third property, one diagonal bisects the other diagonal. Now, you'll notice that's pretty similar to something we learned way back when we were talking about parallelograms, and I want to say this was theorem 7.7, that the diagonals of a parallelogram have to bisect each other. Here, it's only one bisecting the other. So this point in the middle, I'll go ahead and call that point S, there you go, is the midpoint of one of the diagonals, but not both. And which one is it? Again, you can usually tell looking at it. In this case, it's diagonal EI that gets bisected. So ES, I'm going to put a triple tick mark there, has to be congruent to line segment SI. But it is not the case, don't put this in your notes, guys, that KS and ST are congruent. Pretty clearly in this case, ST is longer than KS. One of them will always be longer than the other. Okay, so that would be part 3 right there. And the fourth and final property, one diagonal in your kite bisects a pair of opposite angles. All right, and again, this gets a little wordy here. This angle down here on the bottom is getting bisected right here. Those two angles are going to be congruent, and the same thing happens up here on the top. So I'm going to put a triple tick mark there and a triple tick mark there. That is not the case here, guys. This angle and this angle are not necessarily going to be congruent to each other. So that is the definition of a kite, and then the 4 properties that go along with it. 2 of those are theorems, and the other 2 aren't probably important enough to be listed as theorems on their own here. And I have lost a problem right here. What in the world happened there? All right, give me just 1 second, guys. Okay, so I don't know what happened to that example right here, but I've got it drawn here, so let's map it all out. Pretty quick problem here. We're going to deal with a kite in this problem right here. So I'm going to call this example A, and we are going to find the measure of angle A in this diagram right here. So my diagram isn't going to look very good, guys. Sorry about that, but I'm freehanding this diagram right here, and I need to tell you one pair of congruent sides right there. Notice they're consecutive, and a second pair, and that's all you need to know that we are dealing with a kite. I'm going to call this angle A, and I'm going to tell you that we've got a 40-degree angle right here and a 70-degree angle right there. And let me go ahead and label the other 3 vertices as well. So we're going to come up with the measure of angle A. Okay, so how are we going to do this problem right here? Well, what I want to do now is focus on the ideas of angles within a kite here, guys. So that's not going to have anything to do with property number 1 here, but it might have something to do with property 2, which deals with angles here. Yeah, let's run with that. One pair of opposite angles in a kite have to be congruent. So if we look at this figure, angle D and angle B are opposite angles. They're on different ends of the kite, but pretty clearly you can tell that these 2 angles are not congruent to each other. So that's not the pair of angles that have to be congruent. It's got to be the other pair then. It has to be angle A and angle C. So whatever the measure of angle A is, I'll go ahead and put an X right there. Angle C has to be congruent to angle A. Because of that theorem, let's go back to it one more time, that says one pair of opposite angles in a kite has to be congruent. And again, it's not B and D, so it's got to be A and C. So I'll put another X right here, and let me go ahead now and add up the 4 angles in my kite. X plus another X plus 40 plus 70, doesn't matter what order you put them in, equals, well, here's something we haven't said yet in this section here, but it's been true all chapter long. The sum of the interior angles in any quadrilateral is always going to be 360 degrees. The reason for that, guys, is if you remember this formula from way back at the beginning, sum of the interior angles is 180 times n minus 2. Well, in a quadrilateral, n is always equal to 4. So this is 180 times 4 minus 2, which is 180 times 2, that's 360 degrees. So the sum of my 4 angles in any quadrilateral is always going to be 360. And now we have a pretty easy equation to solve. I'm going to combine those two like terms and those two like terms. X plus X is 2X. 40 plus 70 is 110. All of that is going to equal 360. We're going to subtract the 110 from both sides and get 2X is equal to 250 degrees. And divide by 2, we're going to get X is equal to 125. And that is what we were looking for here for the measure of angle A. So let me go ahead and write it out the way that they wanted it here. They didn't ask us to solve for X because I introduced that. So I'll just say that the measure of angle A is going to be 125 degrees. And there's our answer to that problem right there. Okay, so we needed that theorem about one pair of opposite angles being congruent. All right, I lost a diagram here as well. So for B, all right, that is a figure that looks something like this. Let's see if I can draw this one right. Okay. And again, single tick marks here and here, double tick marks here and here. That makes it a kite. And on this problem, I'm going to give you an 80-degree angle right there and a 120-degree angle right there. And we're supposed to come up with, sorry, I didn't write a problem yet here, to find the measure of angle. Let me call that angle L. And I'll label everything J, K, L, and M. Okay, so we are interested here, guys, in knowing the measure of angle L right over here. So it's going to be the exact same problem right here and basically the same property. This one just presents a little differently. We've got one pair of opposite angles here that have to be congruent. So either the 80 would come straight down right here and these two angles would be congruent, which I don't feel real good about, or it goes across right here, and these two angles would have to be congruent. Well, because of this vertical line of symmetry in this particular kite here, it's that second case, guys. Angle M, let me get rid of all of this junk right here. Angle M is going to be 120 degrees as well, which is going to leave us with X right there for angle L. So again, we'll make a pretty simple equation out of this. X plus 80 plus a 120 and another 120. All of that is going to have to add up to 360 yet again. So this one's maybe even a little easier than the last problem. X plus, 120 and 120 is 240. Plus another 80 there is going to get us 320, if I'm not mistaken. That's going to equal 360. Let's subtract that 320, and we're going to get X is equal to 40 right there. Okay, gotcha. So what do we know? The measure of angle L is going to equal 40 degrees. All right, so hopefully neither one of those is too tough. I know there's some problems on the 7-6 worksheet that deal with that concept. This is an old problem I had from my notes a long time ago. I like this one a lot, decided to keep it in here. The directions here tell you that ABCD is a kite. So we know that it's a quadrilateral with two pairs of consecutive sides congruent. But you'll notice the diagram doesn't give you any tick marks, unlike the diagrams in the last couple of problems. So we don't know which sides here are congruent to each other. And that's the question. Which sides have to be congruent in this figure right over here? So the way we're going to handle this problem is to realize that there's a very limited number of options for what could be the case right here. BA, I think, is the key side in this figure right here because we're given the measure of BA here at 4x minus 5, and we know, or at least we have variable expressions for, the lengths of the sides on either side of BA. So that 4x plus minus 5 right there has to be equal to either 3x minus 7 or 22 minus 5x. But it's really not clear from the diagram which it is. So we try something and we see if it works out. So what I'm going to run with right here, what I think most people kind of tend to guess right here, is that maybe this piece right here, 4x minus 5, and the 3x minus 7 are the congruent sides. Let's see what would happen if that were the case. 4x minus 5 would in that case have to be equal to 3x minus 7. Now, if I subtracted a 3x from both sides, I would also want to add a 5 on both sides here. That cancels. That cancels. And I'd end up with x is equal to negative 7 plus 5 is negative 2. Now, nobody likes it in geometry when you get a negative value for a side length right here, but that by itself isn't necessarily a problem as long as your side lengths and angle measures all work out to be positive. So let's explore that idea now. Let's let x equal negative 2 and see where that gets us. 4 times negative 2 is negative 8. Minus 5 is a negative 13. And right here, guys, I know that my initial assumption that I made right here can't possibly be right, because there's no way in geometry that a side length can ever be negative. Now, just for fun, I really don't need to check this. If x were negative 2, 3 times negative 2 is negative 6, minus 7 makes negative 13 again. And what we've come up with here, guys, is an algebraic solution. It is the case that negative 13 is equal to negative 13, so it makes sense numerically, algebraically, but it doesn't make any sense geometrically because we can't have negative side lengths. So that means that my initial assumption here had to be wrong, and that means that if there's only one other thing that it could have been, that must be the case. That 4x minus 5 and 22 minus 5x, those must be your congruent sides. So let's make sure that works. If it doesn't, that means that whoever wrote this problem goofed up. 4x minus 5 should be equal to a 22 minus 5x. So I'm going to add a 5x on both sides, and then I'll move all the constants to the right, so I'll add a 5 in both spots as well. 5's on the left cancel, 5x is on the right cancel. 4x plus 5x, we get 9x equals, and 22 plus 5, okay, is 27. We'll divide both sides by 9 and get x equals 3. Now, let me get rid of a lot of the markings that I've made a mess of this whole thing right here. But okay, now we're in business, and let's make sure that this value of 3 works out here, guys. 4 times 3 is 12, minus 5 makes 7. That's at least possible. How about right below it, AD? 5 times 3 is 15, and 22 minus 15 is 7 as well. Okay, good. And I just need to make sure this side works out to be something positive. 3 times 3 is 9, and 9 minus 7 is 2. So not by much, but this one does work. So let me answer the question, guys. It didn't say solve for x. Which sides must be congruent? We've learned now that line segment AB has to be congruent to line segment AD. And then the other part of the answer, the only other conclusion then, would be also then that line segment BC, up here on the top right, would have to be congruent to line segment DC. And that would be the answer to this question here. So we had to figure out the value of x in order to be able to answer this question. But the actual answer is given right here in that green box. All right, guys, that's everything I got for you there on section 7.6 on trapezoids and kites. So let's dive into the homework there, guys. Good luck with everything, and let us know when you have questions.